All right. So, good afternoon, everyone. Today we will be discussing the Bhavan Vidyalya paper. It's a periodic test, obviously, of class 10 and mathematics. Not be mentioning that, but okay. Right. So, this paper happened yesterday, I think, and yesterday's date would be 20th May. All right. So, without further ado, let's begin the test. Now, first question is, if the HCF of two numbers is given to you, HCF is 145 and the LCM is 2175. And if one number is this, find the other number, right? Now, I know the relationship that HCF into LCM is equal to first number into second number, as in the product of it. HCF 145 into 2175 is equal to 725 into the second number that you're actually interested in. So just transpose this, divide by 725. You can get the second number as 435, which is the answer. All right, moving on. Now he says, check whether 6 raised by n can end with the digit 0 or not, right? And it is a 1 marker. Heavy question. Okay, cool. Now, digit 0, that means I need to have a factor of 10, right? That means I need to have 2 into 5, as in both 2 and 5. So let me write the prime factorization. So prime factorization of 6 is 2 into 3. So 2 into 3 raised by n. So 2 into so on into 2 n times. Into 3 into so on into 3 n times. Now I need to check whether in the prime factorization I have 2 into 5 or not. Now 2 is definitely present. But what about 5? 5 is, if 5 is absent, that means 2 into 5 is absent. That means 10 is absent. That means factor of 10 is not there. So that means 6 raised by n cannot end with 0. All right. Moving on to the next one now. Now he says if 1 0 of the quadratic polynomial. So this is my quadratic polynomial. First of all, let me write it in a better way. Collect the like term. So 2x square plus 6 minus 6p into x minus 7. Now he says if 1 0 is the negative of the other. So if 1 0 is 5, the other 0 is minus. If 1 0 is minus 3, the other 0 is 3. If 1 0 is alpha, the other 0 is minus alpha. Right? So this he says. Then find the value of p. Now alpha minus alpha. I think if I add the two zeros, right, the answer should be 0. Sum of zeros is 0. So sum of zeros I can use the coefficients also, right? So negative of coefficient of x. So 6 minus 6p divided by coefficient of x square, which is 2, is equal to 0. So that means 6 minus 6p is equal to 0. So minus 6p equal to minus 6. So p is equal to 1, which is the answer. All right, moving on. Now he says in class 10 there are 32 students. Section A, 36 students in section B. Determine the minimum number of books required for their class library so that they can be distributed equally among students of section or section. Equally, right? Okay. Now, suppose I need to have the books for section A. Okay, let's see, 32. Right, 32 kids are there, so maybe I can have 32 books. I'll give one book to each student. Then I might have 64 books. I might give 2 books to each student. Then I might have 96 and so on. Can you see what I'm writing down over here? I'm writing down the multiple. Right? Similarly, for the books for section B kids, either it can be 36 or it can be 72 or it can be 108 and so on. Again, the multiple. Now he says distributed equally, right? So that means I'm looking for the number which is present over here, which is present over here. So I'm looking for the common multiple. And he says the minimum number of books. That means I'm looking for the lowest common multiple of 32 and 36. And I'm sure you can easily find it out. And this actually turns out to be 288. 288 can be equally divided among students of section A and section B. All right, moving on. He says if the sum of zeros of the quadratic polynomial is equal to the product. So sum of zeros, I can write using the coefficients, right? So minus 2 divided by k. Or I should say negative of coefficient of x, which is 2, divided by coefficient of x square, which is k. Now this sum is equal to the product. So let me write the product, constant term, which is k, divided by coefficient of x square, which is k. right? Obviously, k is a non-zero quantity because quadratic polynomial, so coefficient cannot be 0. So I can cut this. So minus 2 by 3 is equal to k. All right, moving on. Now he says write a cubic polynomial whose zeros are this. Now, if 2 is the 0, the factor is x minus 2. If minus 3 is the 0, my factor is x plus 3. Minus 1 is the 0, my factor is x plus 1. So multiply the 3. First of all, I'll multiply these two. So x square plus x minus 6 into x plus 1. So this is x cube plus x square plus 2x square. Then plus x minus 6x minus 5x minus 6. This is the cubic polynomial whose zeros are 2, minus 3 and minus 1. Moving on. Now he says if alpha beta are zeros of the polynomial this. N square minus 1. You need to write the zeros. Zeros are clearly visible. 1 0 is 1. The other 0 is minus 1. Right? Now he says find a quadratic polynomial whose zeros are this and this. So if I take alpha to be 1 and beta to be minus 1. So I have my 2 alpha by beta is equal to 2 into 1 divided by minus 1. So that is minus 2. And 2 beta by alpha, that is 2 into minus 1 divided by 1. Again, that is minus 2. Right? So my zeros are minus 2 and minus 2. So that means my thing is x plus 2 into x plus 2. So that is x square plus 4x plus 4. This is my quadratic polynomial. Now you can say, ma'am, you can take beta to be minus, you can take alpha to be minus 1 and beta to be 1. Absolutely, you can do that. But since this these expressions are symmetric, it doesn't matter. You'll get the same polynomial. All right. Okay. Moving on. Now he says find the largest positive integer that will divide 398, leaving the remainder 7. I need to find an integer that will divide 398, leaving the digit remainder 7. I need to find out this number. Now the thing is, I know factors, I know multiples, right? I do not know what happens when the remainder is something other than 0. I do not know what happens, right? So I want my remainder to be 0. If I want 7 to become 0, I need to subtract 7. I need to subtract 7. So that means if I take the number 398 minus 7, that means 391, right? This number will be divisible by this one. Cool. So that means I am talking about some factor of 391. Similarly, 436, if I divide by the same number, my remainder is 11. Now, I do not know what happens when the remainder is not 0, right? So, I would want it to be 0. So, minus 11. So, minus 11. That means number 425 is exactly divisible by this. Okay? 542, you can easily find out that actually the number 527 is exactly divisible by this number. So, I'm looking for a factor of 391, 425 and 527. So, I'm looking for the common factor. But he says the largest, so that means I'm looking for the HCF. HCF you can easily find out, it turns out to be 17. So 17 is the largest positive integer that will divide 398, 436, 542, leaving the remainder 7, 11 and 15. Alright, moving on. Now we have question number 9. Oh, prove that 3 plus 2 root 5 is irrational. It is a 3 marker. Alright. So suppose that it is rational. So 3 plus 2 root 5 is rational. That means it can be expressed as quotient of two integers, positive integers obviously, a and b. Positive integers, you need to write it properly. B is not equal to 0. Right? Now I know something about root 5. So I will try to isolate it. So I can write root 5 as a by b minus 3 divided by 2. Now this is a rational number, this is a rational number. And difference is there. That means rational. Right? Now rational divided by 2. That is rational. Now left hand side, we know that root 5 is irrational. This is irrational. Irrational equal to rational. That means what if it's that means there's a contradiction. Right? Hence, your supposition is wrong. Hence, 3 plus 2 5 is irrational. Moving on to the next one and the last question. He says, obtain the zeros of this and then verify the relationship between zeros and their coefficients. Now, I need to find the zeros of this. 7x square minus 11 by 3x minus 2 by 3. Right? What I'll do is, instead of finding the... I lost my question. Oh, I'm back. Okay, back to it. Right, so this is my polynomial f of x, it says. Right, now the thing is, fractions are getting involved. I'm not a big fan. What I'll do is I'll multiply the polynomial by 3. So 3 of f of x equal to 21x square, 21x square minus 11x minus 2. Right, the zeros of f of x and zeros of 3 into f of x, they are the same. Right, okay. So what I'll do is, I'm changing my polynomial. Absolutely fine. Cool. So I will try to find the zeros of this. So basically I try to factorize. So 21 into minus 2, that is 42, and I want my sum to be minus 11. So 3 into 42. 3 into 14, that would work, right? So 21x square minus 14x plus 3x minus 2. 7 common, 7x common, so 3x minus 2 plus 1 common into 3x minus 2. Right, so my factorization is basically 7x plus 1 to 3x minus 2. This is 3 of f of x, right? I want the zeros for f of x, right? So divide by 3. Divide by 3 and divide by 3. In fact, my zeros remain the same, right? Wait a second. I need my eraser. Eraser. Yeah. I was here, right? Okay. Back to it. Back to it. Yeah, so I got my zeros of this polynomial 3 into f of x. My zeros are minus 1 by 7 and 2 by 3. Mind it, the zeros of this polynomial will be the zeros of this one, right? Okay, so my zeros are this, so I can find sum of zeros. Sum of zeros is minus 1 by 7 plus 2 by 3, right? So I can add them up, so 21. So minus 3 plus 7 into 14, so that is 11 by 21, right? Now I will find minus coefficient of x divided by coefficient of x square, which is negative of coefficient of x, so minus 11 by 3 divided by coefficient of x square, which is 7. This turns out to be 11 by 20. Now, sum of zeros is equal to minus coefficient of x divided by x square. This is the relationship verified. You will do the same thing for the product of zeros and you will be answered. Right? So with this, our discussion of Bhavan Vidyalaya paper is done now. Thank you and I will see you.